Okay, so let's get started. Thank you so much for joining. And this is Exploratory Online Seminar number 57, Survey Data Analysis Part 2. This is really around factor analysis and text analysis, basically, how we can use those technique or analysis method to understand your survey data better. Okay, so let me introduce myself. My name is Kan Nishida, CEO at Exploratory. Exploratory is a company we started spring 2016 to democratize data science. Since then, we've been building the Exploratory as a desktop application to make it easier to access various data science methods and technologies. And also alongside, and we all provide training and seminars to share the knowledge and skills. So building the tools and also sharing the knowledge and skills. So that way we think we can contribute to democratizing data science. Prior to starting Exploratory, I used to be working at Oracle, building various data science related products. For about 20 years or so. Okay, so our vision is anyone should be able to make data-informed decisions. And in order to make that world, we think we can contribute democratizing data science. When we say the data science, we think of it as kind of like a data science workflow. So that you start with the business questions or problems, and you want to address that questions, right, or problems. And then you need the data, so you want to access the data, and you want to transform the data to get that ready for visualizing the data or analyzing the data to understand or discover the trends and patterns in the data. Once you find insights that help you answer the business questions, then if you are working by yourself, then that's the end. But most of the time, like, you work with others, so you need to communicate those insights effectively. So we think data access, data wrangling, visualization, analytics, and communication, those are the important 5 steps. So Exploratory provides more than a simple UI to do these 5 things. Okay, enough about Exploratory and myself. Let's get started. So Exploratory Online Seminar number 57, Survey Data Analysis Part 2. We have done a part 1. You can check out the past recording. I'm going to show you how you can find it at the end of this seminar. But this time, this part 2, we want to go into the factor analysis and text analysis. Okay, so let's start with the factor analysis. This is a kind of brief introduction. So factor analysis is about, this is a statistical method for discovering latent commonalities among correlated variables. Gosh, there's so many weird words. So basically, when you, in this like a survey data analysis context, right? So you ask a bunch of questions, maybe like the 5 or who knows, maybe like 15 questions to the responders, and then they answer those questions. So in this case, though, each question is considered is each variable. Okay, and then we want to find some kind of latent commonalities among those questions. Even like when you ask like 10 questions, some of the questions might be similar, the way, responders answers. So if you can find such commonalities, that will help you segment your responders or customers or students or whoever. So then, you can sort of like segment, and then you can take, different actions, for each segment. Or you can, understand the characteristics of each sort of like a group. It's kind of similar to clustering. Okay. And basically, like, we want to find, and this is a cool thing about factor analysis. And so we want to find the underlying characteristics or some kind of motivation, if you will, that leads the customers or the responders to answer the way they answer those questions. So it's sort of like, if I stretch enough, like, it's almost like you want to find why they answer the way they answer those questions. So that's the kind of information you want to find. So And also, you want to find that sort of like a relationship between the questions. So you you ask 10 questions. Maybe like some of the questions are closer to each other and some of the questions are completely different. So you want to find the relationships. And then that way, it helps you to design your survey. What type of the questions you should ask, what type of question you actually don't even need to ask, that kind of stuff. Okay. And this is pretty, to me personally, it's kind of cool theory. It's kind of like a philosophical in a way, a little bit. But this person, George Spearman, in 1904, I hope like his first name is correct, but this person is pretty famous statistician. One of the theory he was talking about was like unobserved factors determine what we are able to measure directly. So there are things that we can measure, but there are things that we cannot measure. And but for example, like the survey is a good example. Like you can actually measure by asking those questions and then measure like how they respond. So those are the things that you can measure. But some of the things like you can't really measure, it's hard to define. It's good example is, for example, the happiness. And you want to increase the happiness of the employee, and how you measure the happiness. And then it's kind of like a stupid to ask like, are you happy, right? And then everybody answer random scores, but that doesn't really help you understand if they're really happy or not. So you instead, like you ask like, are you satisfied with the salary? Are you satisfied with the job, or whatever, how many hours you work, or, what's the relationship with the boss, and that kind of stuff. And then based on that, like you measure if the person is happy or not happy. So that's a kind of a simplified version of it. But let's get more practical one. So let's say like you have a bunch of beers, right? And how do you decide? I'm assuming everybody loves beer. But how would you pick the beers? Depends on people, right? Okay, so some people might pick the beers based on how they look, or how they smell, or maybe how they, heard about, before, how you choose. And then, so we basically decided to ask questions to, people, and, maybe like a color, or maybe the taste, maybe the cost, how much is the beer, or, reputation based on like how how did you hear before? So there are like 7 questions. Okay. And then, maybe like, I don't know, 10, 100 people, whatever, like you ask them to score from 0 to 100, and you get this result back. And based on the way they responded, seems like some group of the people tend to score higher for something like a color or aroma or taste. But then they don't really score high on other aspects of the beer. But then certain group of people tend to score higher for the size, alcohol, cost, right? So, and then like another group of people tend to score higher for the reputation, but not so much for the other questions. Okay, so it looks like there are like 3 groups of the people, right, based on how they answer, or like the scores they made for each question. Okay. And then based on how they choose, maybe we can label it. In this case, the top, like I label it as a quality, like they really care about like a color, aroma, taste. It's more like a beer aficionado a little bit, right? So they care about the quality of the beer. But the second group, the blue group, is they care about the price or cost, right? So like size and alcohol. I'm not sure like alcohol should be considered as the cost, but maybe like less money to get higher alcohol. That's kind of crazy. But so size, alcohol, cost, maybe like they care about the cost. And then the last one, reputation. So basically they care about the brand. Like this is like a microbrewery from this so and so made this one like last year, that kind of stuff, right? So they care about that. Okay. And then basically those are the left-hand side. Those are the things like it's called like a commonality. So like looks like, for example, the quality is kind of common thing for color and aroma taste. And also though, here's one point is that quality is not only for the color and aroma taste. These people that we label the quality people, they also care about alcohol, size, cost, reputation, but not as high as the color, aroma, taste. And the same thing for like cost sensitive, the brand, and so on as well. And another thing about this is that, for example, the color, the question of color, like do you pick this beer based on the color? And then, so that's actually can be explained by, people who, think about, care about the quality, but certain aspect, it's not like everybody score in the same way for the color. Maybe like something that like there's a variance that way they answer for the color. So that is something called uniqueness. So something that it's so unique to this color question that cannot be explained just because they care about the quality of the beer. Okay, and so that's a red color part. So each question has its own uniqueness, and then but also has a commonality that can be shared among the variables. So that's really the kind of basic of the factor analysis. So it's really about that, finding the left side is like a commonality among the variables, and then we can label these variables as a quality variable, cost sensitive variable. But not only that, you can label the people who score high on those variables as a sort of quality people or cost sensitive people and so on. Okay. So going back to the original data, so this is how the responders responded. And then looks like like Renee, Tom, Bob, they score high on this cost size alcohol questions. And then like another group scored high on those quality variables like a color, aroma, taste. And then like some people who score high on the reputation. So when you look at the data, there's some kind of trend or pattern like this, and that's a factor analysis going for. And then now this kind of I switched to the row and column a little bit. So now the variables are positioned at the left hand side in a row. So cost, size, alcohol, color, and so on. And then the columns are now is like a factor 1, factor 2, factor 3. And what this means is the factor, I basically created factors, 3 factors, and I try to see like a commonality. And then like first one, the cost. And the cost is really explained by the factor 1. And the size, alcohol as well. And there's some differences among those 3. And then that means factor 1 is really about the cost. And then there's something that size and alcohol, as well. And then because factor 2 is color, aroma, taste. So by looking at these numbers that you can see like how much that each variable can be explained by the underlying the factor. Okay, and then the right-hand side, there's a uniqueness column and a commonality column. And this is that uniqueness that like I was talking about. So for example, the first one, the cost, it's almost like this one, the uniqueness is 0.01. And so it's almost like kind of close to 0 in a way. So there's not much unique about the cost. So like whoever, answer this like a, high on this cost size alcohol, so like a cost sensitive variables, they tend to answer in the same way for the cost. So there's nothing kind of unique to this this cost variable after the commonality. And then, so commonality is basically like 1 minus uniqueness. Okay, and then the size and alcohol, and there is, huge amount is like explained by this, factor 1, but there is something more, data has more variance in these variables because some people answer like higher and then lower, and then not really in the exact same way as much as the people answer for the cost. Okay. So this is actually the result you will get when you run the factor analysis in exploratory. In exploratory right now, the commonality is not going to be in that same metrics, but uniqueness is going to be there. We're going to take a look after this. Okay, and then the you get those like a factor 1, factor 2, factor 3, and then it's actually your job to label what the factor 1, factor 2, factor 3. I mean, you don't have to, but it's, at the end, you tend to do it because then it's easier to explain, what are these questions are, and also what are these people, can be categorized as. Okay, and then this one is like right now row. Each row represent each variable, but in reality, like you want to know like how you can categorize each responder or each customer, each student, and so on. So then like you get this result as well. So the right-hand side, side, 3 columns, FA1, factor 1, factor 2, factor 3. And then each has a score. So like basically when you see the higher score, and then like you see, oh, okay. So for example, the first one, Renee, has a higher score on FA1, factor 1. So this person tend to be more cost sensitive than the other people. And then, but not so much on the quality and brand compared to others. And in this way, you can sort of like, hey, like I want to focus on like this cost sensitive, customers because like we want to promote, we want to do some campaign for like a discount campaign or send a coupon or something like that. I don't have to send all the responders. I can pick and choose who I should send to. And then I can use this factor 1, which is a cost sensitive variable, sort of like a group. Okay. So then one thing though is that factor analysis, like you have to decide how many factors that you want to set. It doesn't, calculate this number of factors automatically. So in the previous example, we have 3. But that doesn't mean that it has to be 3. It can be 2, it can be 4, it can be 5, any numbers. And then like that's kind of like sort of like then how should I decide? So that this is how it helps. It's actually there's something called script plot. And then this is very similar to k-means clusterings elbow method. So basically this is like a y-axis is something called eigenvalue, but what the goal is to reduce this sort of like the value. So the smaller is that means there's not much, like that. So okay, x-axis is the number of factors. So 1, 2, 3, 4, 5, 6, 7. And as you have more factors, then basically, like let's say like you started with the 7 variables, and then you create 7 factors. Basically, that becomes exact the same as the original set of the variables. So that that's not going to help. So like basically, when you have 7 variables and you want to shrink into like a 3, then you can see like 3 categories of those variables, right? So there's a trade-off. Like less factors. That means you can basically categorize what are those variables, but then more factors, that means you're not even categorizing, you're just presenting as is. So where is that, that kind of optimal point? And that is that when you see the script plot and then like this curve goes down, and then like the amount that or the amount or ratio that this curve goes down, it gets a certain point settle. And that's where around, hey, if you can keep adding more factors, but then that way, I mean, you're not really, finding much more commonalities, reducing the uniqueness there. So in this case, the number 3 at the x-axis, and after that point, it's kind of like a saddle. So probably like optimal number of factors is in this case a 3. And then another way to see is when you see like something like, let's say like you set number of the factors to be 3, And then there's one chart that gives you like factor importances, like a number, factor 1, factor 2, factor 3. And then this basically is showing like how much of the variance that each factor can explain. And then, basically like if you add more factors, eventually this like orange line, the cumulative percent variance ended up to 100%. So, and then that's fine, but then again, then you have original number of the variance is 7, and you ended up with 7 factors, and you're not really doing any categorization or anything like that. So that's the trade-off. And in this case, looks like I set number 3 and then 1, 2, 3, and it seems like the first one and second one really explain the variance in the data, and then the third one add, and then at that point, it's almost like 80 to 90% of the variance being already explained. So that's pretty good. And then you go to that weight table, and then you see the one like I presented before. I'm going to show you quickly on this because this one is kind of like there's a simple example, the exact same one. And I'm going to just do that here. There's a beer survey data. So this is basically this underlying data, same data that I was showing in the presentation slide. Okay, so like you have like 7 columns, and then there's some different information. It's like which group or like other sort of like a customer attributes. But in this case, like go to the analytics, and then I'm going to select this like a factor analysis, and then variable columns. I'm going to select the cost to taste. These are like 7 columns or 7 variables, and click OK, and then click Run button, and then here it is. So like I have like a cost, article, size, and then in this direction, this is like a biplot chart. So what's really doing is like try to express original variables by using the factor 1 or factor 2. I explain what the factor 1, factor 2 in this case. And then, but you can see sort of like a relationship among the variables. And then when you see the variables going the same direction, that means those tend to be the similar questions, or the way responders responded are very similar. In other words, they're very correlated. So like the people who score high on the color tend to score high on the aroma and so on. Okay, and then same thing for this here, like these questions, people tend to score in the same way. And here's the reputation. They tend to score in a very different way from other variables. And this dot represent each observation, in this case, each responder. And then you have like a much less, because we had like 231 rows, but somehow like you don't see like 231 dots. And that's because I think this kind of score tend to have an exact kind of same score, and in that case the dot is on top of each other, so that's why probably you're not seeing it. But what this is for example, there are people here who tend to score high on this one, and then the people here tend to score high on this one. That means, for example, the opposite side of reputation for here. So these are the folks that tend to score less on the score. Okay. So having said that, and then another thing is that you can set this color thing. For example, let's say like a group or something. Let's say like you have the group, and then it seems like, I don't know this group, let's make it simple. This is like maybe boys and girls, men and women or something like that. Then maybe the men, let's assume like it's simple for the simplicity, blue is man, and then orange is woman or something like that. And then these folks tend to score higher on the cost, article, size, and maybe like an orange group tend to score low on those cost side, but they tend to score high on the color and maybe high on the reputation and so on. So you can see sort of like a relationship between these factors that are sort of like latent variables and the customers' attributes. Okay, and this now here, when you go to the weights table. And this is the one like basically like we were seeing in the presentation slide. So if I click on the fact one, and then, so taste, aroma, color. So this one is like a super high. So it seems like these are the sort of like factor one. Then at this point, I can label factor one as a cost sensitive factor, and then factor two as no, actually not the cost sensitive. This is like a quality or beer aficionado, variable. And factor two is the cost sensitive, and then and so on. In this case, though, like we have only factor one, two. And so should we, have like this, factor one, two, is this good enough? It seems like the last one, reputation, is not really explained well by the factor one, factor two. Instead, like there's a uniqueness. So it seems like reputation is super unique, 0.61. So maybe like we should add more factors. And then that's where you can go to the script plot, and then you see like here factor two at this point. And if we add another factor, and then it seems like the variance can be shrink even farther. So maybe like we should add to the three. And then you can go to that property, number of the factors, and then increase three and apply. And then now when I go back to the weight table and there's a factor three, then here is this like minus. That means it's like it's opposite from the others. So, but it's actually the absolute value wise is close to 1. So, okay, so this one is pretty that can be explained by the factor 3. So we can say like a factor 3 is the brand or reputation variable, even though there's only 1. Okay. So that's a brief introduction. And then this is a beer survey, but let's say like you had something more employee satisfaction survey or something. Let's take a look at another example here. This one has each employee answer these questions. There's not many questions, but if they are passionate about their current work, their current job is important. Their overtime. This question is asking about the overtime or not. They work hard or not, not hard, longer or not. And then here is amount of work. And you might have guessed it. These two kind of similar questions, but they answer anyway. They question anyway. And then here is a salary related to questions. And then this is about the boss, gives you appropriate feedback or not. And then this is about the company, like do you support your company's mission or not? And then there's a sex and age, those are employee attribute information. Okay. And the same thing, you go to the analytics, and then in the part 1, we look at the correlation, we look at the PCA, principal component analysis, and we even look at the clustering. And today, like we want to do the factor analysis. So here, like select the factor analysis, basically doing the same thing, nothing unique about it compared to the beer survey analysis. And then I can just click on run button, and then I get this result. So it's again, same thing, like the way you interpret. So this one seems like these two passionate about current work and considering current job is important. This seems to be like a very similar questions. Here, satisfied with amount of work, current overtime level is acceptable range. This seems to be like similar questions. And then there are other questions seems like slightly different. How many factors we should create? And this one seems like number 3, number 4, around here, it started getting settled. So maybe like a 3 or 4. This is kind of hard to judge, but let's start with 3. And at the end of the day, how many factors? Also, important thing is like how you can explain each factor. And if it's too, subtle difference between the factors, that point you are having too much of the factors. And anyway, so here when I go to the weight table, and then here's factor 1. And the factor 1 is basically this is passionate about current work, consider current job is important. So these are like almost like they're satisfied with their job, or like sort of like a contentness. And then like factor 2 is this like a work volume. So satisfied with amount of work and overtime. So, this is something to do with amount of the work they have. And factor 3 is this is like something about the company's mission. Okay, and this one though, it's that seems like boss gives appropriate feedback. This one, if anything, explained by the factor 1 and factor 3 in the opposite way. Minus is kind of less, and positive is more. But uniqueness is 0.71. So it seems like this is not really explained well by the existing factors. In this case, factor 1, 2, 3. Okay. Okay, so that's the quick snapshot, nutshell of the factor analysis. And then in the previous seminar, we took a look at the PCA principle component analysis, and there's a difference, and it's very similar. And in a way, you don't. I don't think like you should sweat too much on this case factor analysis, this case PCA. Sometimes kind of like overlap, but the fundamental difference between them is sort of like kind of like a design or like strategy is different. So the factor analysis is really about finding the underlying or latent, like factors that drive the responders answers the way they answer, right? So you have like set of the variables, but those are the observed variables. But you want to find unobserved variables that actually affect the way they answer the questions. And as opposed to the factor analysis, the PCA is it generates a new artificial variables, right? So this is not necessarily the latent variable. It just creates new variables, like principle component 1, component 2, and so on. And the whole point of the generating such new variable is to explain the original information or original data variance with fewer variables. This fewer, reduced number of the variables. So it's more like you can use it for like a dimensionality reduction technique. So those are the difference. And if I picture it, the factor analysis that like this. So like you have the latent variables or underlying unobserved variables, right? And that drives the people to answer in a certain way. So the center is the observed variables or in the data. Okay, so this arrow, the direction of the arrow is very important. So what are causing, the way they answer the questions? And PCA is the arrow is start from the observed variables to artificial variables. So maybe like these variables to create PC1, PC2, PC3, and then here is try to have the fewer variables. So maybe like at this point like you can have the PC1, PC2 to be able to explain all the variance in the data. Then like that's good enough to have just PC1, PC2, and then of course the PC1 tend to be representing certain on the variables, but it's not about grouping the characteristic. It's about the less variables to represent original data. However, you tend to get a similar result between the factor analysis and the PCA. So that's why, like I was saying, like I wouldn't recommend you sweat too much, because at the end of the day, if you want to find sort of like a similarity among the variables, and then you can find this, kind of you ended up getting a similar result. Okay, so this is the factor analysis, and this is the PCA, and then especially when you are designing which survey to ask. Typically, people use factor analysis, but even the PCA, you can find which variables are similar to one another. So you can use both of them. Okay, but the kind of design or the strategy is different between them. Okay, so that's the factor analysis and the PCA. So the next topic is I like to move on to the text analysis. There are two topics in here. First one is word count. So this one is pretty simple. So I'm going to just quickly move on to the demonstration. Here, survey text data. So more often than not, you have this type of question where responders can enter sort of like a free text, right? Hey, can you describe this product, or can you describe the experience of the customer service, and so on. And this one is, I think this is like an NPS survey, and then NPS is score from 1 to 10, and then the question is like, hey, would you recommend this product? Would you recommend this seminar to others, and so on? Okay, and then another question is that usually you see that kind of text box underneath and say, hey, can you explain why? This one, what would it be? I think this is, I guess, how would you recommend to, improve this seminar or something like that? Okay, so you have this text, and then you want to understand what are the trends in the text data, like what are the words that people use, what kind of things people are talking about without reading all those information. So if you have only 10, by the way, or 20 questions, 20 people, then you probably don't even need it. You just kind of read through it and you get that picture. But when you have tons of people answering the questions, then you kind of confused. And also another thing is like, sometimes the question has a strong comment, and then you ended up getting so distracted by the strong comment. Can be super excited, super nice, happy comment, but usually like kind of very negative comment. And then as if like you feel like that is the all, like all the experience that people got from your seminar or your product and so on. But when you start, translate this to numbers, then you can make more objective judgment, in terms of like how they think about your seminar or product and so on, or service and so on. Okay, so for this, you go to the analytics, and then underneath, you want to find text analysis, and there are two things. And the first one, let's go with the text word count, and then you select the text column. So this is like the column that we had, and then click run button. And the first thing you're going to see is a word cloud. And then, so behind the scene, what it's really doing is it separates the word, right? So for example, in this case, this is like a supplementary explanation. So separate by the space. And then the first text becomes maybe like, 12 words or 13 words and so on. And they do the same thing for each row. And then basically counting up, to see like what are the words that most commonly used among all. Okay, so in this case, you can see like time and think these are like the two biggest. By the way, this one is a size and color, basically like representing the same thing, which is a frequency, like how many times that word or given word appears in all the data. So here, time and think and a better presentation. These are the common words. So this one's kind of like a cool to see, presentation slide and so, but it's not really to see like a real trend, because you can't, it's so hard to compare that between the time sync and better presentation, those words. So I would recommend here the words bar. And then this way, you can see like how often, for example, this word called time is used in this all the data as compared to other words. Okay, so like it's almost like this one is compared to other words, it's almost like a 3 times, more common. And then the next one, the think, and then better particular presentation, and so on. So this one, like x-axis is the frequency or number of the times or the counts, and then the y-axis is each word. So this is like a top, I think this is a top 20 or so. You can change it from the property. Here is a number of the bars, default to 30. Okay. And then another one is that basically here words per bar. So which words are used together sometimes like, what this time means, time better or time to think or time series analysis, what time really mean. So that this word pair bar helps you to get some clue on like how the time is. For example, here, so time and management. So this sounds like something to do with time management in this context. And it looks like there's a time presentation, something about the time for presentation. And then maybe here that looks like a end time and finish time. So some people don't care about somehow like end time. Usually like maybe it didn't end on time or something like that. So you can see like what combination use more common and so. Okay, and then by the way, I have here like this one is like how often used together, but certain word, for example, there's like a use case, and this is obviously like, for example, maybe like a should be the one word. This, I'm not sure this is a good example, but let's say like, hey, the use cases, I mean, like this gotta be like the same word. And like, I don't even want to separate like as a different word. And in that case, you can actually adjust it. So here, let's say there are a bunch of parameters. And one of the things is commonly used is a stop word. So in this case, the default is exclude the stop word. So like remove stop word is yes. If I didn't set this yes, so the default is yes. But if I set it to no, then you're going to start seeing this or that or or that or those types of words that like often shows up in any documents or any text. So we don't want to get distracted by those. So that's why like remove the stop words. And then you can add additional stop words or you can exclude some of the stop words. And if, for example, like if I don't know, some brand you're working on, and then like this is the word that like, it actually means your, name of the band, brand. In that case, you want to set this from here. And another one, so this is the one like I was originally wanted to talk about, is here, maybe like this use case. Hey, this is actually the same word. So like I don't want that to be separated. In that case, you can actually give this one. And if you have other one, for example, like, the machine learning, for example, hey, these are the one word. So like I don't want that to be separated, then you can actually give it like this as well. In this data, I don't have the machine learning, so I'm going to remove it. And then if I click on apply button, and I think the use cases is going to be show up as a one word. Okay, so I'm not sure like use case is still there. Maybe like I should go to the word bar, and then that is not, maybe like as use cases, not as common as others. Maybe that's why it's not even showing up. Another thing I noticed though, here's a case and the cases. And that's actually kind of tricky one. There are a couple ways to deal with this, but in this case, I'm gonna quickly do the data wrangling from here, work with text data and then replace text. And then, for example, those cases to be just case. And then, so here the cases, that becomes case. And then I'm going to just run it. And in that way, all the cases to be case. And then from this point, I'm going to just move the pin button and then run it again. And I see like how that the order is going to be different. Might not make any difference. So here the case, now it's actually case become the number 3. And that's cool. And then, but what pair the use cases now is use and case. And that's because that's here. Now, like I should make this a use case. And then how that is going to change. And then word bar and then use case. Not so much. Oh, here, use case at the very end. Okay, so there's a use case here, and I wonder, so this one is the case. So this case is actually not used in a use case, like a case by itself. And this use case is actually next to each other in the original data. So that's actually 7 times. So not as common as I originally thought, but you got what I meant, hopefully. And then another stuff is a word pairs network. So this way, this is actually kind of an extension of the word pair bar, but what pair network is, it's more like kind of you want to see kind of at the high level, what are the relationship among those words. So in this case, that this size represent the frequency or the number of the counts that each word appeared in the data. And then this line, the thicker and then thicker and therefore darker, this thing is basically represents the same thing, and meaning that relationship, so like a time management or time presentation, they tend to be used more often than the other combinations. Okay, so that there's that. And the position doesn't really mean anything. So just because presentation is above time doesn't mean anything. Time and the presentation is super close. That also doesn't mean anything. It doesn't mean much. What it means is this strength of the relationship is represented by the line thickness or the color in it, color, and then in order, so they tend to be closer if they are sort of like a thickness of the line is thicker, because that's a kind of printing power. But when you have all those things together, then you can't really see each of the dots. So that's why it uses some algorithms to kind of separate each circles from each other. However, still it tend to be similar. So like, for example, here, this like a pink color, around similar, I mean, like a close to one another. That's because the pulling power is kind of like big to pull each other. However, here is there's like a better, and then maybe like a deduce. This one has a strong relationship, even though they're separated, and that's because better also has a strong relationship with a think. So I don't know what that means, the better think, but anyway. So that's why the better is kind of separated from this like a pink group. Okay, so what here is, and also the color represents, it's kind of like a similar words. I mean, like a what do you say, like close to one another in terms of like how they use together. So for example, this increased number, what is this? Reduce presenters. So these type of the words tend to be used together. And orange, time, presentation, management, and much, and they tend to be used together. And here is the studies and the cases, so they also tend to be used together, and so on. Okay, so you can see sort of like an overall picture of the relationship among the words. Okay, and then last topic, I want to move on to that last topic of today, which is the text analysis and topic model, or maybe I should say like document clustering. Okay, so this one is using something called topic model, and one of the algorithms is called LDA, latent delete allocation. I'm sure like I'm pronouncing wrong way. But anyway, a type of statistical model that automatically discovers latent topics in a collection of documents with probability. This seems to be very similar to factor analysis. Basically, we want to find some latent variable, in this case, latent sort of like topics that can explain the relationship between the documents and the words. So what that means. So you have the document on the left-hand side. In this case, each answer of the survey is a document. Okay, and then like you basically take out all those words. I mean, like each sentence becomes a word and then separated. And so that's the right-hand side. Okay, so the first one has a government, Republican, Democrat, Congress, Olympic, and a moratorium or something like that in that document or in that text. Okay, and then when you analyze this, and then like you can start seeing like a similarity among those words in terms of like how they use together, how often they use together, and then that's the topic or latent variable. So in this case, it looks like, hey, this government, Republican, Democrat, Congress, these type of words tend to be used together, and Olympic, baseball, tennis tend to be used together, and so on. And then this, again, the label is the human does it. So we have to label it. But this machine or computer or algorithm gives us some kind of a categorization of it. Okay. And then that means, okay, so each document consists with certain words, and they're not necessarily only politics. And sometimes the document has something, some of the words that tend to be used in the politics environment, but also some in economy related environment. So in that case, this first one cannot be said this is a politics, maybe economy too. But then it shows a ratio. Let's say 80% of the words from this document is politics and 20% is economy. So then this one is more likely to be politics, and so on. And the second one is also the same thing. The third document is also the same thing. So that you score each document this way. And that's basically the very nutshell of the topic model. So let's try to do this. I'm going to just duplicate this. And then this is I call it like a topic model. And then I'm going to just remove this this use case thing. It was not really useful in the previous demo. So I'm going to just remove it. And then I'm going to click apply. This is going to just run it. And then what are we going to get is basically behind the scene. Oops, I did something very unuseful thing. So this is word count. I had to change this one. Instead of word count, we wanted to do text clustering with topic model. That's what that topic model is. And then when I run it, it's basically doing the same thing. It dissects each document into pieces of the word. And then from there, the last one, the word count, was just there, and then how to visualize, how to analyze that data. Here is try to find the latent variable or the latent topic, and then find the relationship among those. So let's start with this one, important words of topics. So default, we have the topic 1, 2, 3. Right, so we have 3 topics. And then left-hand side seems like this is like a case presentation analysis and so on. And the second one is a time better particular presentation. Seems like this is the one that kind of got maybe complaining about the time, I think. And then the third one is a material and nice session. Seems like kind of a positive word here. And then you can see, for example, what each topic is talking about. So for example, this topic 1. So these are the original texts that was scored higher on the topic 1. And so this one, for example, I'm still beginner in data science. There are maybe things, terminology I don't know. So please plan seminar for beginners. And this one is a presentation. So you can see some sort of like a word. The second one is a various demo. This is a presentation. So it seems like a presentation and demos they're talking about, and use cases appeared here as well. Here's the use cases as well. Okay, and the topic 2, what is topic 2? That one is the one like I think something to do with time. So it's like there's people like using fast time, but here like presentation is a little short. Presented time, some restrictions are presented at time. So something to do with the time management. Looks like 10 minutes is something to do with the time. So you can say like this topic 2 maybe something to do with time management or something. And then what is the topic 3? And then this one is overall, seems like they like this seminar. So like I want you to make a series. I want to make a another one. So on. And then this is again like how many topics, default is 3, maybe like you can increase the number of the topics, and then you can see maybe like each topic is sort of like unique from one another here. And then here is like again a time management, and maybe better, meaning should be time management be better. And the first one is cases, use cases. So this one something to do with the presentation use cases. And the third one is about maybe like analysis or particular topic of the seminar and so on. And if you're not sure what each topic means, then you can always go back to topic of documents to see what each topic really means. Okay. And then, but this one is basically like, okay, so we have like, how many topics in this data and then what types of things they talk about. And that's, the kind of thing that you can understand. But when you go to the data, this is where, so each correspondent, each maybe customer or student, and then what types of things they're saying. And then by looking at, topic. So for example, the first person is considered as higher on the topic 1. And then, okay, so these are not only you can see their comments, but also by using this, you can categorize, maybe like, I forgot which one. So you remember the time management is, topic 2. So then you go to find a topic 2. So these are the folks that complaining about, or they're not really happy about time management, for example. It's not, necessarily like exact match, but you can find a tendency of like, what type of people or who are the one, more gearing towards the topic 2, in this case, the time management. Okay, so that's pretty much it. Okay, for today. So today, basically, like I covered 3 topics. Number 1, the factor analysis, which helps you to find underlying or unobserved measures or variables based on the observed variables, basically, or based on the questions that that your responders answered. And then you can find some sort of like underlying characteristics of the users or customers and students and so on. Okay, so that's a factor analysis. And then, but that was about the, understanding the numbers, right? Number data, usually 1 to 10 or 1 to 100 or something like that. But the second and the third topic is about text data, like when you ask questions and ask them to enter some, comments or something like that. So there are 2 ways I introduced today. The first one is that, word count. So really based on the word and what words are used more common than others, and also what pair of the words are used together or similar to one another. And the second one is to find a sort of latent topic or underlying topic that people are talking about based on all the text data. And based on that, like you can just see, not only find out what are the latent topics or topics of the comments, but also you can, again, categorize or segment that customers or responders. And therefore, like you can take certain actions more effective way. Okay, so that's it for today. And the online seminar, like in order to find a past recording or future seminars, you can go to our website and under the Learn, and then you can go to the online seminar and then go to the online seminar page and find more information. And the next seminar next week, Wednesday next week, I'd like to introduce time series data. How you transform those data, how you visualize those data, and then how you analyze by using, statistics or machine learning algorithms. Okay, so please stay tuned. And then, okay, and that's it for today. So with this, it's already 12 in the Pacific time, but I like to open a question session. If you have any question, please ask. Please ask. Oh, there's a chat window. Okay. Okay. Oh, great. Positive comments. That's good. I'm going to keep these positive comments in that data. So that therefore, next time I do the text analysis, good comments in that data. Okay.